Welcome to 5A, which is simplifying radical expressions. So for the warm-up, we're going to list our perfect squares. So that's like 2 squared is 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 36 is 6 squared, 7 squared is 49, 8 squared is 64, 81 is 9 squared, 100 is 10 squared, 121, 144, 169, 196, and I think 225. They keep going, but really the main ones I want you to focus on is up through 100. Those are the main ones. You might every once in a while have to bump up and know some of these other ones, but you can always use the calculator for those. Now when it comes to perfect cubes, that is going to be 2 to the third, which is 8, 3 to the third, which is 27, 4 to the third is 64, 5 to the third is 125, 6 to the third is 216, 7 to the third I believe is 343. The reason why I believe it is I have not checked, and I really don't think we're going to need it very often. Once we get to numbers bigger than like 125, I really just go straight to the calculator. Like if I needed to know what 6 to the third was, I would put it in the calculator, or 7 to the third, or 8 to the third. Perfect force would be 2 to the fourth power, which is 16. Then 3 to the fourth power is 81. 4 to the fourth power is 256, I believe. And after that, I don't know. So really, these, typically we don't memorize them, but if you want to, you certainly can. Definition, x is the nth root of a real number if, on real number a, if hold on. Sorry. If x to the n equals a. So if 3 is the square root, so that's the nth root, square root, that'd be the nth root, so it's second root of 9, it's because 3 squared equals 9. So kind of following, instead of x, I'm going to put 3 in there. So a real number a, so 9 is a real number. So the x, the 3, is squared. So squared, and then that would equal 9. All right, when it comes to labeling, so the little number inside here on the side, the little check mark area, that is called the index. That is going to tell us what type of radical it is. So if there's a 3 there, that's a cube root. If 4 there is a fourth root. If there's nothing there, it is assumed that it's going to be a square root. The little symbol is called the radical. It's the radical symbol. That's what that is. And then underneath, we call it the radicand. Underneath the number, the term in underneath the expression. If there's no index, it is assumed that it is a square root. Kind of what I just said before. If there's no number here, we assume it's a square root. So about square roots, I've seen some confusion with like the negatives and what happens to them. When it comes to square roots, the square root of 25, we all know that's 5. So the square root of 25 is 5, but then there's a negative on the outside. So then you multiply by -1, which is -5. Now in this bottom one, we have the square root of -25. That's the square root of -1 times 25. And the square root of -1 is I, and the square root of 25 is 5. So that one's actually 5i. So that you see that putting the negative in different spots can give you different answers. Down on the bottom here, filling these in. Nothing crazy about these. Square root of 16, nothing different. It's 4. Square root of 121 is 11, and then there's a negative on the outside. 289, I believe, is 17. Down here, cube root of 8 is 2. Cube root of 343 is 7. cube root. Now, cube root, we can cube root negatives. I know this is going to be, that kind of goes against what your beliefs are. You can cube root negatives. So if I have a negative 5 cubed, that's negative 5 times negative 5 times negative 5. And that would equal 25, when you multiply two of them together, times negative 5 is negative 125. So it means if you get a negative one way, you got to get a negative back the other way. So if I cube root negative 125, it's going to be negative 5. So down on the bottom, fourth root of 1 is 1, and then there's negative on the outside. Fourth root of 2401 is 7. And I would just put that straight in the calculator. Fourth root of 4096 is too big for my brain. That's just going to be 8 when you put it in the calculator, and there's a negative on the outside, so the negative will come with it. Now, dealing with these fractions. When you're working with the fractions, you can actually simplify the numerator. You can do the radical of both, the square root of the numerator and the denominator. So the square root of 4 is 2. Square root of the 25 is 5. So cube roots work the exact same way. We have the cube root, and the negative I'm just going to put up to the numerator, and the cube root of 27. You see I did the negative up to the numerator in the first problem too. Cube root of negative 1 is negative 1. Cube root of 27 is 3. And the denominator, or the last problem, fourth root of 81, and the fourth root of 16. Fourth root of 81 is 3. Fourth root of 16 is 2. So make sure you look and think in fourth roots, not square roots. All right, let's take a look at some problems here. So I'm not going to do all the problems, but I'll do some of them. I'll start with number 1. So simplifying radicals, 117. I think about what's the biggest perfect square. So now I'm thinking about, this is a square root. So I have to look back, and the students I see are successful with this, look back to this page. I'm looking at perfect squares, so what I have highlighted here in green. So I think about what's the biggest number I can divide out of 117. Well, 117 is not one of those numbers, so then I just start going down and thinking about, and let me pull up Desmo so you can see what I'm doing. I do a lot of this in my head just because I've had a lot of practice with this. So I got 117, and I'm going to divide by 81. Nope, that's a decimal. I'm going to divide by 64. Nope. I'm going to divide by 49. Nope. I'm looking for a number that's a whole number. 117 divided by 36. No. 25. No. 16. No. 9. Yes, there we go. 9 and 13. So my biggest perfect square is 9. So I'm going to replace the 117 with a 9, and it was times 13. And then I'm going to rewrite this. You don't have to rewrite it like this, but some of you might want to see this. I'm going to write right below. The square root of 9 is 3, and that's times the square root of 13. You don't have to write the little dot for times. When you put a number next to the square root, automatic means, that means multiplication. So no dot is needed. That just means 3 times the square root of 13. All right, I'm going to do number, I'll do number 2. So the 4 on the outside is going to stay a 4. It stays on the outside. And we got to think about what's the biggest perfect square that divides out of 320. So again, I'm going back to the first page, 320. I would put that straight into the calculator and see, is that a perfect square? So square root's down below, and it's not. So then I'm going to take 320, and I'm going to divide by, usually I take a number that's about half. So that'd be about 169. That's a perfect square. Nope. 144. Nope. 121. No. Some of these you can do in your head. And with more experience, I would know that 320 doesn't divide by 100 without a decimal. 81. No. 64. There we go. 64 is my biggest, so 64 and 5. So I'm going to go back here, and I'm going to write 64 times 5. Now, you might not split it up like this. You don't have to. You can keep them underneath if it helps you. underneath one radical. So they have 4 times square root of 64 is 8 times the square root of 5. 4 times 8 is 32, square root of 5. Okay, let me do another problem. So I'll do number 7. So I have 3, and it's a fourth root of 162. So now I'm going to look at fourth roots. So back here, fourth root's 167, not one of those numbers. So it's either got to be divisible by 81 or 16. So 162, I believe that's 81. 162 divided by 81, and it is. It's 81 2, perfect. So I'm going to look at that and break up the fourth root into 81 and 2. The fourth root of 81, we know that is 3. And then we don't know what the fourth root of 2 is, so we're going to keep it that way, because it's going to be an exact answer. So fourth root of 81 is 3, and then the fourth root of 2. And then 3 times 3 on the outside, multiply, always multiplication on the outside when a number comes out. And then we got 9 times the fourth root of 2. All right, when it comes to variables, don't be scared. When it comes to variables, square roots, exponents being multiples must be multiples of 2, cube roots be multiples of 3, and fourth roots multiples of 4. So let's get rolling on this. So I'm going to do number 9. So your number, I'm going to break it up like this. So you have 32. We're going to do that first. And then it's going to be x to the 4th and y to the 9th. So the 32, biggest perfect square that divides out of 32 is 16. So from the first. And then that's going to be square root of 16 is 4. So that's going to turn into 4 square root of 2. Now, let's concentrate. This is our new part, is our variables. So I have 4x to the 4th. You can write it like this if you want. How many groups of, it's a square root, so how many groups of 2 can you take out of 4? 1, 2. For each group, it'll come out as just 1x. And there's nothing left over. Now, when it comes to the y's, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. How many groups of 2 can you take out of 9? That looks like 4. So that's going to be times y, times y, times y, times y. Each grouping comes out as 1. Because really, it's y times y is y squared. And the square root of y squared is y. So that's why there's only one that comes out. And there's this y that's left over. So there's no pair with it, so that's going to stay underneath the radical. So now we got to put this together, and hopefully this is not confusing. We have 4's on the outside, times x, which is x squared, times y times y times y times y, which is y to the 4th. And then what's left over on the inside, we have a 2 and a y. And that's your final answer. So that is 5A. Hopefully that helps you. And come to class or advisory with any questions.